I hope this is going to feel like a really easy lesson for you because you have done it. I think when we get into literal equations where the letters come into play a little bit more, that's always a struggle in Algebra 1. So it might be a little bit of a struggle just getting back into that. But this first stuff is like algebra at its core. So solving equations, okay? Here are just 3 steps for you to follow when you're solving equations just to make sure that you're doing the right thing, okay? Number 1, write down the equation you're solving. Now, the beauty of Canvas and the way we do things now is I don't need you to handwrite it. If you want to just copy it from the book and paste it into your homework, that's you writing the problem, right? So go ahead and do that, but you may not just write an answer, okay? I need to see the problem and what you did to it. So make sure you're showing your work, being detailed. It's good for you. Number 2, use a column form. So when you're solving it, you write it down and you work down. We want to say like, I subtracted 4 here and I subtracted 4 here, right? I want to see how you got to where you got this way. Math, well, I guess for you guys would be this way. Math this way is not as fluid, and people seem to make more mistakes when you work horizontally. So column form, okay? And then show all your steps. Show me what you're doing. If you do those things, you're going to be in great shape. All right. If you can't do this problem, I'm going to be concerned. X plus 4 equals negative 12. How do you solve that? Subtract 4 from both sides. So you subtract 4, you subtract 4. We get X equals negative 16. Okay. It's good, right? We know how to do that. Yeah. Okay, this one. Number 2. We're not adding anymore. What are we doing instead? Dividing. Okay, so with this one, you'll notice if I divide by 24, remember we always do inverse operations. We always multiply or divide if we're dividing or multiplying. Do the opposite of what it is. So if we're multiplying here, right, 24 times b, we want to divide. So divide by 24, divide by 24. Now, if you plug that into your calculator, 50 divided by 24, you get 2.0833333333. That's not a pretty answer, okay? When you get a funky decimal, okay, it is preferred that you leave it as a fraction. So 50 over 24, you're just going to reduce that fraction. What are 50 and 24 both divisible by? 2. Okay, so if I divide by 2, 25 and 12, you can't reduce that any further. So that would be your answer. Now, here's something for you. If you plug this into your calculator and you get 2.083 repeating on your calculator screen, how do you turn that into a fraction? Do you know? See this button right below alpha? It says math. We love that button. It's very helpful. You're going to hit math, and that very first thing says what? Frac, right? It means fraction. If you hit enter right now and then enter one more time, 25 over 12. Look at that. It does the work for you. So just know you have a button on your calculator that will help you turn things into fractions if fractions have been problematic in your past. Okay, step it up a notch. Example 3 here. What do you do first? Distribute. First thing we want to do is we want to distribute. So we're going to get negative 27 plus 6y equals 3y minus 9. Now, technically, there's not a step you must do next, but there is a step that I will always do next here. What would you do next? Subtract 3y. Yep, get your variables together. Subtract 3y, subtract 3y. When we do that, this goes away. You get negative 27 plus 3y equals negative 9. What comes next? Yeah, now we want to get everything away from our variable, right? So we're going to add 27 to both sides. So you get 3y equals 18. And what is our last step? Divide by 3. Is it nice to kind of like ease into algebra 2? Like, oh yeah, I know how to do this stuff. I know how to do basic algebra. We're good. We're good. Questions on that? Okay. Do example 4. You may do it with your neighbor. You may do it on your own. I recommend a neighbor just to chat through things. But give that a go, and I'll work it out with you in just a minute. Here's how it goes. So hear me on this. This one you're going to distribute, right? This is 6x minus 3. Here's where you need to be careful. This is a negative 2. We're going to treat it like a negative 2, right? Now you could distribute the 2 and then distribute the subtraction. That would be silly. Just distribute a negative 2. So negative 2 times 3x is a negative 6x, and negative 2 times 4 is a negative 8. Okay? No more parentheses, because when you distribute, those parentheses go away. All right? So you have this equal to 11x. Now we simplify. 6x plus or minus 6x. Minus 6x, right? We keep the symbol that's in front of it. So if I go 6x minus 6x, what do I get? 0x, right? It goes away. So these are gone. Okay. What number is this? Negative 3. Keep the sign in front, okay? So negative 3 minus 8 is a negative 11. So on the left, we have negative 11. On the right, we have 11x. What do? Divide by 11. So x is negative 1. Good? Okay. Special cases. So there are some situations where it won't look like what we've been doing right now. There are some that will, some that won't. You good? Okay. So if it is an answer that is sometimes true, okay, a problem that is sometimes true, that means we have one solution. That means our answer will be something like x equals 5. Okay, that is a situation where it's sometimes true. X can equal something. X can equal 5 here. Okay, there are situations where it is always true. We call that an identity. Okay, that's when you solve a problem and it ends up looking like this. If it's like 7 is equal to 7, okay, or negative 3 is equal to negative 3. That's an identity. That means your situation is always true for any value of x. It is always true. Okay, identity. When it's never true, we say that is no solution. And that will happen when your answer comes out to something like 9 equals 4, right? 9 is never equal to 4. So there will be no solution to that problem. Or negative 16 equals 0, right? No solution. Okay. So let's take a look at these next two and see if they are sometimes true, always true, or never true. All right, so number 5. What would you do first? How do you simplify this? So if we just start on the left, right? 11 minus 7 can be simplified. So that would be 4 plus 3x on the left. What do you get on the right? 3x plus 5. 6x minus 3x is 3x plus 5. What's your next step? Add, subtract, multiply, divide. What would you do next? Subtract what? Yeah, move those x's. So if I subtract 3x here, then I have to subtract 3x here. Well, wouldn't you know it? They just go away because those are both 0. So I have 4 equals 5. What does that mean? It is never true, right? 4 never equals 5. Therefore, you have no solution. Okay. All right, you simplify number 6. Work that one out. 6x minus 2x is 4x plus 5. This is 4x plus 5. Now here's the deal. Technically, you're done at this point because they're identical on both sides. But if you want to do it one step further, right, you get 5 equals 5. So that is an identity. That is always true. 5 always equals 5. Okay? Questions on that?
No.
Awesome. Okay. Here's where in Algebra 1, it starts to get a little hairy for some. But we're in Algebra 2 now.
Yes.
So we're gonna get this figured out just fine. When dealing with what are called literal equations, it's basically saying you have multiple variables. I want you to solve for this variable that's on the wrong side of the equation right now. It's with a bunch of other stuff. I want you to isolate this certain variable, okay? So these don't come out to like x equals 4 or y equals 7. You're not gonna get a nice pretty answer like that. You're gonna get whatever variable they ask you to solve for by itself equal to a whole bunch of other stuff depending on how much stuff we started with, okay? So don't feel like you're incomplete if your answer looks a little funky. It might be totally done. That's okay, okay? So if you look at this first one, this one's pretty straightforward. If we have to solve for C right now, if we have to isolate C, what do we need to do? Subtract. Take away the 273. Okay, that means K minus 273 is equal to C. We isolated C. We've got our answer. Does that make sense? Okay. Look at the next one. This one's a little bit fancier. They ask you to solve for B here. So we're trying to get B by itself. Okay? Get this B all by itself, which means we need to get rid of that 1/2 and we need to get rid of the H. You could do it in one step. I don't recommend it. I'm not going to do it that way. I'm going to do it in 2 steps just so everyone can see how we do what we do. What would your first step be? If this were you solving a problem, what would you do first?
Divide both sides by H.
Okay, you could divide both sides by H. What would you do, John?
Multiply by the reciprocal.
Okay, which would be?
2/1.
When a fraction is 1 over something, you're really just multiplying by the denominator, right? Which is multiplying by the reciprocal. That's what I would do first. Henry, it's not wrong to do your way first. You'll get there just the same. But for the sake of what I feel like most people might do first, I'm going to get rid of the number first. So I'm going to multiply by 2. Technically, it's 2/1. You can just write it as 2 because 2 times 1/2 is 1. But whatever you do to one side, got to do to the other. It's the golden rule of algebra, right? So I am left with BH on the left and 2 times A on the right. We're trying to isolate the B. So now I'm going to do Henry's step and divide by H. So this is 1. H over H is 1, which means I have B equal to, I can't simplify anything else there, so I just leave it as is, 2A over H. Does that make sense? Any questions on that?
Never.
Seriously, Clara, I'm going to be so sad when you're not here. You're so encouraging.
When Michael left.
What?
When Michael left,
Oh, that was sad, huh?
that was bad.
Yeah. All right. Example 9 here. Okay, we're solving for x. Now this one you do have to do certain things first. You kind of do PEMDAS in reverse on these, okay? So we're going to add and subtract and then multiply and divide when rearranging this, solving for x. So what's the first thing we do? Subtract 5 from both sides. So right now I have x over m equals y minus 5. Okay, now you gotta be a little bit careful. We're trying to isolate x. So what's the step? What are we doing?
Multiply by m.
Multiply by m. We're doing the inverse, right? We always do the opposite of what is already happening. Right now it's x divided by m. So we're gonna multiply by m. But why do I say we have to be careful with that, do you suppose? Henry?
You have to distribute m to everything on the right side.
Right, so we need parentheses. We need to multiply the whole thing by m. So you get x equals, now here's the deal. I don't need you to distribute it. If you want to leave it just like this, I'm fine with that. You have isolated your x. This can be your answer. If you like to take it a step further, you could do my minus 5m. That's fine too, but you don't have to. You don't have to take it to that next step. Questions on that? So just doing the opposite of what is there. Okay, try this one. This is isolating x again. This whole problem was solve for x. So get x by itself, what would you do? Okay. And the division bar is different. Division bar, this right here, when it's the division bar, it kind of acts like parentheses. So I know I told you add and subtract first and then multiply, divide. That doesn't happen on this one because of that division bar. You're actually going to multiply, divide first and then add and subtract. Who wants to tell me what they got? Anybody? Nobody? You're going to be bashful. Okay, who wants to tell me what they did first? What was your first step? Multiply by 3. So if I multiply by 3 here, 3 over 3 is 1. But then I have to multiply by 3 on the right using what? Parentheses. We need to multiply the whole thing by 3, okay? Oh, got step. So we have x minus 3 on the left equals 3 times a plus b, okay? And again, if you want to distribute that, that's fine. You don't technically have to here. We're trying to isolate x. We're trying to get x by itself. What would your next step be to get x by itself? We're going to add 3. Add 3. So technically, if you left it like this, I would not mark it wrong because you isolated your x. Okay, so this is a perfectly good answer. Maybe some of you went a step further and called this 3a plus 3b plus 3. That's a perfectly good answer too. Okay? Questions on that?
No.
Do we love algebra?
Yeah.